Respected professors, dear colleagues, good morning. It is a great honor and privilege for me to be here today at the Polymer and Mediterranean Fiber International Conference 2025, organized by the Laboratory of Advanced Polymer Materials in collaboration with the Faculty of Technology at the University Abdurrahman Mira of Bijaya. First of all, I would like to sincerely thank the organizing committee for giving me the opportunity to share my research work with such a distinguished audience. Allow me to briefly introduce myself. My name is Zohra Shemesh. I am currently a PhD student in the Laboratory of Membrane Processes, Separation and Recovery Techniques, Faculty of Technology at the University Abdurrahman Mira of Bijaya. My main research interests focus on the removal of heavy metals and organic dyes by adsorption on the lamellar double hydroxides in aqueous solution. In order to present this work, I have organized my presentation according to the following plan. I will begin with an introduction, followed by a theoretical background. After that, I will move on to materials and methods, followed by results and discussion. And finally, I will conclude with a summary and conclusion. In the facet of human activity, water plays a critical role, and in recent time, water has emerged as a natural resource to be managed efficiently for sustainable development. Pollution of the aquatic environment by organic dyes and heavy metals due to urbanization and industrialization is a serious problem worldwide. Their toxicity, their non-biodegradable nature, and persistency in the food chain pose great threat to the living organism. Several industries have contributed to this problem, with the most prevalent contaminants being heavy metals such as chromium hexavalent and organic dyes such as methylene blue that are the most challenging pollutants to treat, as chromium hexavalent is highly toxic and carcinogenic even at low concentrations, and methylene blue is a persistent synthetic dye with low biodegradability and harmful effect on both aquatic life and human health. In this regard, separation and purification technologies are necessary in the chemical engineering field for the effective removal of such pollutants. Various approaches have been examined to eliminate chromium hexavalent and methylene blue from wastewater, including membrane filtration, ion flotation, flocculation and coagulation, photocatalytic degradation, and electrochemical methods. However, these techniques require high energy consumption, significant investment, considerable maintenance, and operational costs. Particularly, adsorption, that is characterized by its lack of toxicity, high stability, and low cost, is preferred over other techniques. Lamellar double hydroxides are the most promising materials using in adsorption. In this work, we focus on the comparative study of the adsorption of chromium hexavalent and methylene blue using iron aluminium lamellar double hydroxides. To achieve this goal, the objective of this work is to evaluate the adsorption performance of iron aluminium lamellar double hydroxides on the removal of heavy metals and organic dyes by optimizing different parameters and comparing their effects on adsorption efficiency. Before addressing the core of this study, it is important to briefly define adsorption, that it constitutes the central process investigated. Adsorption is a physical phenomenon in which molecules adhere to the surface of solid materials via physical forces or chemical bonds. There is a wide range of adsorbents such as alumina, zeolites, and silica gels, but lamellar double hydroxides are the most extensively used for the treatment of water contaminated by heavy metals and organic dyes due to their high adsorption efficiency, specific physicochemical properties, low cost, and easy of preparation. Chromium hexavalent and methylene blue adsorption tests were conducted in batch system under well-defined operating conditions. A solution at a known concentration of each pollutant is brought into contact with a fixed mass of iron aluminium lamellar double hydroxides. After adsorption, the filtrates were analyzed by UV visible spectrophotometer. Now, we proceeded to a comparative evaluation of chromium hexavalent on methylene blue, on the removal of methylene blue and chromium hexavalent using iron aluminium LDH. In this part, we investigated the influence of different K parameters in order to identify the most favorable conditions for each pollutant. The effect of contact time between the adsorbent and adsorbate, as well as the initial concentration of chromium blue and of chromium hexavalent, and methylene blue were investigated. The results shown in this figure reveal the same trend for the both systems. Adsorption kinetics are rapid in the early stage and gradually slow, where the equilibrium is approached around 30 minutes. We also observed that adsorption efficiency increases with the increasing of initial concentration, reflecting the stronger gradient reflecting the stronger gradient of concentration between the solution and the adsorbent surface. We have also observed that We also observed that methylene blue is adsorbed more efficiently than chromium hexavalent due to its cationic nature, which increases its affinity for the adsorbent surface compared to chromium hexavalent. We have also examined the effect of adsorbent dosage. The equilibrium adsorption as function as adsorbent dosage reveal that the amount of 2 grams per liter provides the optimal adsorbent dosage for the two systems studied. pH is an important factor in adsorption process, as it influences the charge of the adsorbate molecules and adsorbent dosage and adsorbent surface. Regarding the absorption of chromium hexavalent on iron aluminium LDH, the absorption efficiencies decreases gradually with the increasing of pH. The results obtained reveal that 1.56 is the optimal pH for this system. This behavior is attributed by the fact that at pH 1.56, the chromium hexavalent species present in solution are anionic in nature. Given that the pH point zero charge, given that the pH 0.0 charge is determined to be 5.98, the adsorbent surface is positively charged under these acidic conditions. Moreover, the adsorption process observed in this study appears to be governed by attraction electrostatic. Regarding the absorption of methylene blue on iron aluminium LDH, we observed that the absorption efficiency increases with increasing pH, reaching optimal efficiency with a pH of 7.22 under similar experimental conditions as for chromium-6 adsorption. In order to determine the optimal steering speed on the adsorption efficiency of chromium hexavalent and methylene blue on iron aluminium LDH, the adsorption tests were conducted over a range of 0 to 600 RPM. The results shown in this figure reveal that 300 RPM is the optimal steering speed for both systems. In conclusion, iron aluminium lamellar double hydroxides showed excellent adsorption performance toward methylene blue and moderate efficiency toward hexavalent chromium. This difference highlights the strong electrostatic influence between the pollutant and the adsorbent surface. Iron aluminium LDH remains a promising, low-cost and stable material for the removal of various pollutants from water, and I thank you for your kind attention.